Here's an old Trigon power supply that I just rebuilt, upgraded it to a degree. It was made back in the day when germanium transistors was the mainstay, although it does have silicon rectifiers in the rectifier assembly, but the original TO3 transistors were germanium TO3 transistors, and because of that, I had a relatively large fan cooling them, continuous AC fan, relatively limited output, all based on the size. It did have 15 amps output at maximum of 15 volts. And I rebuilt the unit using TO3 silicon based transistors and newer IC based voltage control circuit to produce a power supply that would put out about 20 amps at 24 volts, and the current output is tapered down to 0 volts to limit the power dissipation off the series regulators, which is what the TO3 transistors are, and to do away with the loud, noisy, continuous fan, I put in a DC fan and have it running off of a temperature management circuit back here that I built with a little thermocouple, not a thermocouple, but thermal resistor mounted on the heat sink, so as the heat sinks heat up to a certain point, then the fan will start coming up to speed and maintain fan cooling until the heat sinks get down below a certain point. That way when you're using it very lightly loaded or unloaded, then the fan ain't running at all until the thing starts heating up under moderate load or heavy load. Then the fan will come up to full speed to maintain cooling required for the heat sinks and for the power dissipation. The transformer is relatively stout, and two pretty decent sized capacitors across the main voltage rail, and I have one capacitor on the output. I left that configuration in place. And as I said though, just basically took out everything else and put in a new circuit. I'm using LM301 op amps for the voltage control, driving a TO220 field effect transistor, which in turn drives the bases of the shunt regulator transistors. This circuit is designed to fold back the current as the output voltage drops to 0. That is of course to limit the power dissipation of the shunt regulator, because if you maintain 20 amp continuous current at the full bank voltage, which is around 30 volts, you'd be dissipating close to 600 watts in the shunt regulator, which would be even a bit much for the transistors I have in place to take. So I have it tapered down to around 10 amps at 0 volts output, and it goes up to a full 20 amps at 24 volts, and it's continuous current output, fully adjustable by the current and voltage control knobs on the front, so when you short it out, the power supply doesn't just trip out, it just drops down to its regulated current set point, which is the problem with the old power supply before it was rebuilt, because if you'd have even a smallest current spike on it, the whole power supply would just shut down, which severely limited its usability. Alright, I have it turned on, and our output shorted, and our current turned to maximum, so that'll start heating up the heat sinks, and you should see the fan start coming on in about 30-40 seconds. It takes about that long for it to heat up and cold. Alright, starts coming up to speed slowly. There's a glide range where it doesn't just go from 0 to full speed. As soon as it crosses a certain temperature set point, there's a glide range where it slowly comes up speed faster and faster as the temperature comes up. And it's running at full speed. And turn the current down to 0, and in a minute, so it'll start throttling down. And if you set the current about halfway at short circuit, it'll find a happy medium where it's running kind of at slow medium speed. Now it's starting to slow down. And it'll, of course, slow down to a full stop here in a second. Here we go. And that is the freshly rebuilt Trigon Electronics power supply. Don't really know what age it is and the model number and stuff, but it looked like it was built for some telecommunications related stuff a long time ago. The stuff that I removed no longer needed anymore for this power supply after I'd redesigned it. It's quite considerable. A whole pile of diodes, metal cased NPN and PNP transistors, transformer that was supplying the voltage for the control circuit, lots of relatively large air-cooled resistors, Germanium TO3 transistors, which is a shunt regulator, and lots of extra capacitors which supplied the voltage to the control circuit, plus their rectifier assemblies, plus TO3 sockets which I can use on other projects. Heck, there's enough here to build a whole nother power supply, or a couple power supplies, just out of the parts I no longer need on the one I rebuilt. And these are the transistors that it used originally in the shunt regulator portion. 2N1530s Motorola and TR346s. They're rated for a pretty respectable dissipation, but the maximum operating temperature is relatively low, so because they're germanium, so I thought it best just to take those out of the circuit and put in modern silicon transistors they can better stand the heat. As I said, there's a lot of them in there. I can use these on some other project. They're all good shape, but not project that requires high temperature, that's for sure, certain. So, that's it. See you in the next project.